So we now know that the optimal equilibrium is to extract 150 tons in the first period and save the rest of the 100 tons for the second period. But what if the future is not considered, right? Suppose the company doesn't have the right for 2 periods, therefore it only maximizes the current benefit, right? Then how much will be harvested in the first period now and how much is going to be left in the second period? Well, that's obvious, right? Because in period one, will simply choose to maximize their own net benefit. Therefore, they will extract 200 tons. So we established this 200 tons very early on. That is the optimal amount if the only current period is considered. Okay. Now in period two, then they have no choice, but they only have 50 tons available to them. Let's see if we can quantify this effect. Okay. So all right. So let's consider this. Let's consider the demand curve, right? This demand curve represents the market demand. It will give us the price. Okay. So go ahead and draw. We can go ahead and draw a line just to indicate the demand curve here. This is 150. Okay. Now let's suppose that let's plug in. Let's plug in. At the optimal, right? So at the optimal, right, we have 150 tons, for the first period and 100 tons for the second period. Okay, but I don't want to graph all of it here, but I just want to show you what are we doing, and so what we're doing is we are plugging in the quantity, right, into the demand curve, and this is the price that we get. And I want you to focus on the change in price. So right now, think of this as the fair price or the optimal price. Right? In the first period, we should be paying $112.05, and the second period, then they will be paying $125. Okay, this is under the optimal allocation. Okay, but what happens when it's not optimal? What happens when the current period maximizes their own benefit? Okay, now what we see here, the effect here is that the current generation, right, pays less. Right, we get the benefit of paying less, but that comes at the expense of the future. The future generation have to pay a higher price. Okay, and what that gives us is this. Right, what we can see is in the first, the social welfare in the first generation, right? The maximum social welfare for both periods is this. Is all of the area under the curve. A1, that's the first period, plus these three, A2, and then B1 and B2. Okay, this is all in the second. So in the parenthesis here, that is what the second period consumes. Okay, that's the benefit to them. But at the suboptimal, suppose that the first period consumed 200, then the first period is better off because they get A1 and A2. However, the second period, they only get to, because they only have 50 tons, they only get B1. Okay, B2, right? Nobody gets that. Right? The first period didn't get that benefit, neither did the second period. Right? B2 represents the net loss from a suboptimal allocation. Right? Now, so what do we do? Right? How can we? This is not beneficial to anybody. The first period is over consuming because this amount, right? You can think of this last 50 tons here would be better off if we save that for the future. But instead, the first period is over consuming, and we ended up getting this loss of B2. Okay. Now to begin to kind of think about a policy that we can implement, we need to introduce a new concept called user cost. Now, user cost is just the opportunity cost for the future resulting from the consumption of the resource today. Basically, user cost is if we take, or the current period, if the current period consumes anything that the second period might consume, right, might benefit from, then a user cost has occurred. Right. So for example, right, let's take the first few tons here. Suppose that the first period consumes 25 tons. Okay, so consume 25 tons over here. Is there any user cost? Well, the answer is no. Why? Because the second period, right? They wouldn't consume. They they wouldn't consume these 25 tons anyway. In fact, the first period can consume 50 tons and there will be no user cost, okay? Because there's 250, because the second period, the most they want is 200. And so if you leave more than 200, they wouldn't consume all of it anyway. Okay. Now, however, once the first period consumes beyond beyond 50 tons, right, then user cost has begun, right? So user cost has occurred because now the first period is consuming something that the second period would have consumed. Okay. Just because there's user cost, it does not mean that we shouldn't consume it, right? Because we know the optimal is here. So the first period should go ahead and consume, even though the second period would have used it, right? But we need to be aware of it. Okay, all right. So with that in mind, how do we incentivize the current period to extract at the optimal amount? Right. So let's look at some let's look at some policy possibilities.